Today's topic is transmission line types. So, in the previous session, I have told what is the transmission line and why we are going to be needing the transmission line, and what are the advantages of transmission line when we are having the high frequency ranges. So, whenever we are using the transmission lines at high microwave frequencies, the traditional transmission lines are not used, and instead of that we are having a special type of guided media calling as an waveguide. Okay, so these waveguide are going to be used to transmit the microwave signals from one point to another point with a less power loss. So in this session or in this video, I am going to tell what are the types of transmission lines. Under that we are having the parallel transmission line and twisted pair transmission line, coaxial cable, waveguides, fiber optic cables. Okay, so what are the uses of parallel transmission line, twisted pair transmission line, coaxial cable, waveguides, fiber optic cables? Okay, so these are the types of transmission line, and in this session I am going to say with this topic. Okay, so the first one is parallel wire transmission line. So under the types of transmission lines we are having number of types. Why? Because whenever we are having the transmission lines, it are mainly divided into guided and unguided transmission line. That is we are going to be calling as guided and unguided media. Okay, so when we are having the guided media, under the guided media we are having twisted pair cable, coaxial cable and fiber optic cable. Okay, so under this we are having this, and under the unguided it is nothing but calling as wireless. That means we are doing some communication through air. Okay, so like this we are having basically it is divided into two parts, that is guided and unguided medium. Under the guided media only we are having all these types, that is parallel wire type, at the same time twisted pair, coaxial cable, fiber optic and waveguides. So this comes under the guided medias. Okay, so the first one is parallel wire type. So when we are having, the name already indicates that the two wires are going to be placed as parallel. Okay, you can see in this figure like this, you can see this is one line and this is going to be one line. Okay, you can see this, and these two are going to be having separated. That means after a duration of length of the wire we are having a spacers in order to differentiate the longer distance, in order to have the main cable for the long distance. Okay, the distance between the wires is going to be in between 2 and 6 inches. Okay, so this is going to be calling as parallel wire type. And when we are calling as a parallel wire type, initially when we are having two wires or two conductors, the first conductor will carry the original signal. Okay, so the first wire will carrying the original signal and the second wire acting as an ground wire. Okay, so like this the data is going to be transmitting from one point to another point in this transmission line. That means simply we can say that which consisting of two wires and that are going to be closely spaced and separated by air, and non-conductive spacers are going to be used to keep the distance between the two wire constant. That means these spacers are going to be nothing but an non-conductive spacers. Okay, it is not a conductive material, and this is going to be the distance between the wires is in between 2 and 6 inches. Okay, so whenever we are using the parallel wire type, it is very easier to use, but what is the drawback means, when we are saying that the one conductor is going to be carrying the original signals and the other wire is going to be acting as a ground wire. Okay, so when we are having any noise which is attacking the original conductor, that is whenever we calling as the first conductor, so the second conductor is also equally affected with noise. So that means a single conductor is not going to be affected with noise, but both the conductors are going to be affected with noise. So because of this, we are having a larger noise, and we can't remove that noise at the destination part. So for these reasons, we are not going to use with the parallel wire type. That means in the parallel wire type, the name already suggests that it is a parallel. That means the two wires are going to be placed in a parallel position, and the first wire is going to be transmitting the signal, that is data, from one point to another point, and the second wire is going to be, that is second conductor is going to be acting as a ground connection. So whenever we are having some noise affected with the signal, and the signals, not only with the signals, the ground wire is also going to be affected equally as the first conductor. Okay, so because of that, the more noise is going to be getting at the receiver. So original signal is not going to be there at the receiver. Okay, we are going to be getting some other signals instead of the original signal which is transmitted by our transmitter. Okay, so for these reasons, we are not going to use this. And what is an advantage means, it is simple to construct and it is very easier to use also, because there is no shielding, and because we are not having any radiation losses. Okay, radiation losses are going to be very high and easily pick up the noise. That is a drawback under this parallel wire type, and that's why it is going to be calling as open wire transmission line. Okay, this is our parallel wire type. And the next one is twisted pair cable. So in this, the name indicates that it is a twist. That means whenever we are using the parallel wire, in that we are having like this. In the parallel wire, we are using like this. If it is the first conductor, it is the second conductor, and this will be acting as a ground, and this is the conductor using to transfer the data. Okay, so whenever the noise is affected, the two wires, this one and this one, is affecting them in a both same way. Okay, and this affecting of two wires will be affecting our original data. So instead of that, that means in order to remove that interference at the atmosphere effects or otherwise any hikers, so that can be removed by the usage of twist. Okay, so that's why the wire is going to be twisted. Wait some time. So in this, you can see that this is an first wire, so this is an first wire which will be carrying the data, and this is an second wire which will be acting as a ground. So you can see this twist, one twist, second twist, and third twist, and fourth twist. So like this, we are going to be twisted continuously until the receiver gets near. Okay, so like this, number of twists can be done. And what is the use of this means, whenever we are using two conductors, the first conductor is going to be carrying the data, and second is acting as a ground, and the signal is going to be entering from the first conductor. And whenever we are having some interference by the atmosphere effects or otherwise anything, so that will be, the interference can be difference with the first twist. That means some noise is going to be removed by the first twist, and the next twist is going to be used for removing another noise, and like that the all twist is going to be removing the interferences nor noise, whatever it may be, the disturbance is going to be taken out. And at the receiver, if we consider as a receiver at this moment, the receiver will get the original signal instead of getting a interference noise of signal. Okay, so we are getting the original noise at the receiver. Okay, so for these reasons only we are using this twisted pair cable. So this is the reason to use this twisted pair cable. Okay, and when we are having the classification of twisted pairs, we are having two types. Basically, when we are having an EIA, that is Electronic Industry Association, it is an association which was developing about the twisted pairs, not only with the twisted pairs, which will develop them. This is nothing but a standardization which will developing the cables which are going to be used for our communication part. So that association has developed the standards to classify this. That is, in order to have a differentiation, it is classified into two parts, that is unshielded twisted pair and shielded twisted pair. Okay, the name already suggests that it is a shielded and it is unshielded. That means the two cables which are having in the previous figure, that is going to be having an some shield in order to protect our noise or interference which is coming from the atmosphere, and that can be protected to our original cables. Okay, so that can be done with the help of using the shield. So in the unshielded twisted pair, the originally the two wires are going to be shielded with a plastic cover. That means it is nothing but a plastic shield. Okay, this one. And whenever we are having the shielded twisted pair, that is this is an unshielded twisted pair, this is an shielded twisted pair. So the original, the metal sheet is going to be protected both of the conductors, and not only with that, it is also overall shielded with our plastic shield of our device. So it is an shielded and it is unshielded. So some of the applications we are going to be using unshielded, and some of the applications we are going to be using shielded twisted pairs. And not only with this, in the twisted pairs we are having number of types under the EIA, that is Electronic Industry Association. They has given some categories which are going to be used to have a imagination of the quality of the cable. That means based on our application what the cable is should be used, that means that can be given by this EIA, that is nothing but priority levels for our cables. And not only with that, that priorities are going to be used for the introduction of another category of the cables. Okay, like this we are having number of cable categories, and under the twisted pair cables we are having 7 categories. Initially it is division into 7 categories, and that are going to be calling as cat 1, cat 2, cat 3, cat 4, cat 5, and the extension of the cat 5 is nothing but an cat 5e. Okay, so like this, not only with the cat 5e, we are going to be having the cat 6 and cat 7 also. So nowadays we are also having the cat 8 also. Okay, so based on the application, based on the speed of that, that is speed of the data rate that can be used for our application. So in our LAN networks we are going to be using with the cat 5e and cat 6 cables. Okay, so these are used for our LAN connections, that is networking connections, and which are having the data rate is very high, that is about the 200, that is 125 to 200 Mbps. So that's why it is going to be used for our LAN connections. Okay, so this is about the twisted pair. And when we are having the twisted pairs, wait some time. So when we are using the twisted pairs, whenever we are having some cables, the cables cannot be connected directly to our devices. Why? Because in order to prevent that cables, that is very useful to have a connection to our devices, we are going to be using connectors. Okay, so for that, for each cable we are using different connectors. So in our twisted pair cables we are going to be using Rj45 connectors. So what is an Rj45 means? That is registered jack 45. Okay, so registered jack is nothing but he is a scientist who has introduced this connector to connect to our devices. That means whenever we are using these cables, the original cables are going to be very delicate and directly we can't place to our devices. So that's why we are going to be using connectors, and for the twisted pairs we are going to be using Rj45 connectors. In the Rj45 connectors we are having two types of connectors, that is Rj45 male and Rj45 female. So whenever we are using the LAN connections in our homes or in our organizations, we are going to be using with the Rj45 female connector. Okay, so like this we are going to be using the twisted pair cables. And the next one is coaxial cable. So the name already indicates that coax cable. Co is nothing but 2 and ax is nothing but for cutting something, and cable is nothing but a transmission line. So like that we are going to be calling as coaxial cable. Okay, so that means cutting something. So whenever we are using the twisted pair cables, these are not used for our high frequency ranges. So that's why whenever we are having the drawback under the twisted pair, that can be overcome with coaxial cable. So coaxial cable is nothing but which will carry the signals of higher frequency ranges than the twisted pair cables. So mainly the coaxial cables are used for our cable connections for the having the high quality of the signals. And how it looks means the coaxial cables having some inner conductor, that is going to be calling as this. So in this you can observe that the inner that is calling as center conductor are solid or standard wire. Okay, and that is going to be overcome, that is going to be shielded with our an insulator to have an quality, that is in order to not affect the original conductor, we are having an insulator. And above that we are having some a metallic foil, that is mainly used to have an to remove the interference from our atmosphere effects, just like a fog, rainy. Okay, so like that any other conditions which are coming from the atmosphere interference, that can be removed by this braid. So braid is nothing but for cutting something. So like that we are going to be calling as a braid. Okay, which is made up of a copper or aluminium. Okay, so that is going to be acting as an braid for our device, that is the cable. Okay, so that is going to be overcome with an insulator, and totally it is going to be insulated with plastic sheet. Okay, it is nothing but a plastic, it is going to be used as a sheet or to all of this cable. So in order to protect our original data and not having any interference in that, and it should not have any losses to our original signals, like that we are going to be using the coaxial cable. So originally looks like this. This is nothing but a braided shield which consisting of a cross marks. Okay, so in order to remove any interferences to our original inductor or original conductor, so we are having using of this. And you can see the center conductor, and it is having some dielectric material, and above that we are having some foil shield which will be acting as an insulator, and that can be overcome with our braided shield, and which is nothing but an acting as an coax. And when we are having this construction, in that we are having an two conductors. Okay, conductor is going to be insulated with an insulator, and above that it is also having some material, that is the shield, that is acting as an another conductor. So that's why it is going to be calling as co is nothing but an two. Okay, so the center conductor and the outer conductor, that's why it is calling as two, which consisting of two conductors, like that we are calling as co. And axe is nothing but an which will be used for cutting, that is braided shield is going to be used as an axe, and the cable is nothing but a transmission line. So like this we are going to be calling as coaxial cable. And whenever we are using the twisted pair cables, the EIA is going to be having some categories or number of types under the twisted pairs, like that the coaxial cables are also going to be categorized by our radio government, that is we are going to be calling as RG as a shortcut. Okay, so coaxial cables are going to be categorized by using their government, that is radio government ratings, that is RG ratings, we are going to be calling as RG ratings. That means the RG is going to be denoting a specification, that is nothing but an internal wire gauge or the thickness or the type of the internal insulator. So how we are going to be differentiating means it is basically based on some set of physical specifications, that are wire gauge of the inner conductor or thickness of the inner conductor or type of the inner insulator. Okay, and not only with that, the construction of the shield and the size of the insulator and type of our outer carrying also. So based on that, based on the number of parameters, it is going to be categorized like that. So initially the RG rating can be given as, that means a specialized function is going to be given. It is mainly differentiated by three types, that is RG59, RG58 and RG11. So whenever you are having the RG59, that is having some impedance, that is 75 ohms, and it is mainly used for our cable TV connections. And the next one is Rj58, which consisting of 50 ohms and is going to be used for thin Ethernet. And Rj11 is having some 50 ohms and is going to be used for thick Ethernet. So whenever we are having some Ethernet, that is nothing but an wireless LAN technology. Okay, under the LAN connections we are having different types of technologies to be used. So under that we are having Ethernet part. So whenever we are having some Ethernet, that is going to be classified into two types, that are thin Ethernet and thick Ethernet. So based on that we are having some categories of the coaxial cable. Okay, so like this we are going to be using. And under the twisted pair cable, whenever I have said that the twisted pair is not going to be connected directly towards our devices, we are needing some connectors to be used. So like that, in our coaxial cable also we are going to be having some connectors, calling as Bay 1 Neil Concealman is an best example of this connector. So I can say an example, whenever we are using some laboratories, in that we are going to be using CRO, that is cathode ray oscilloscope. So whenever we are using the cathode ray oscilloscope, in that we are having an probe, we are going to be calling a CRO probe. That probe are having some edges, nothing but an, that is calling as Bay 1 Neil Concealman connector. Okay, so in that also we are having number of types under that BNC, and we are going to be calling as BNC T connector, BNC terminator and BNC connector. Three types are there under the BNC. And whenever we are using the BNC connector, is going to be used to connect the end of the cable to a device such as TV set, and BNC T connector is used for Ethernet network to branch. Okay, so like that we are having the number of applications under the connectors. And the next one is waveguides. So what is a waveguide means? I have already told that under the transmission lines we are having number of types, but whenever we are having at microwave frequency ranges, we are not use the terrestrial transmission lines, because the terrestrial transmission lines are not used at our these ranges. So waveguides are going to be used for our high frequency range, that is at microwave frequency ranges. What is the specialty of waveguide means? It is in hollow metallic tube of uniform cross section for transmitting electromagnetic waves by successive reflections from the inner walls of the tube is called waveguide. That means you can see in this figure that whenever we are having some waveguides, it is nothing but two types are there under that are rectangular and circular. You can see in the figure which are having some circular cross sectional area, we are going to be calling as circular. And whenever we are having the waveguide of rectangle, that is length and breadth, we are going to be calling as rectangular waveguide. So it is an hollow tube which is having the uniform cross section for transmitting of waves by successive reflection. That means internally we are having some reflections of the tube is going to be calling as waveguide. Okay, a waveguide is a structure that will be guides the waves such as electromagnetic waves or sound with a minimum loss of energy by restricting the transmission of energy to one direction. Without the physical constant of a waveguide, wave amplitudes decrease according to the inverse square law as they expand into the three-dimensional space. And these waveguides are different types of waveguides for different types of waves. The original and most common meaning is nothing but a hollow conductive metal pipe used to carry the high frequencies, that is radio waves, and particularly microwaves are going to be used. We are having dielectric waveguides are used at higher radio frequencies, and transparent dielectric waveguides and optical fibers are served as an waveguides for light. In our acoustics, that is for the air, we are having as horns are used as an waveguides for sound in musical instruments and loudspeakers. Okay, and specially shaped metal rods conduct the ultrasonic waves in our ultrasonic machinings. Okay, so waveguides can be used in a different way, different types of waveguides for different types of waves. So like this, we are having an dielectric waveguides, and in acoustics, and we are having some horn waveguides. Okay, in the ultrasonics, we are having some ultrasonic waveguides. So number of types of waveguides are there. So how it looks means it is a figure which consisting of a waveguide. So the next one is fiber optic cable. Almost all of you have some idea about the fiber optic cable. Fiber is nothing but a cable which is made up of a fiber material. It is a high plastic material, and optic is nothing but a light. Okay, so the signal is transmitting or receiving in the form of light is going to be calling as a optic. That means the data is in the form of photons. Okay, so the fiber optic cable is also known as optical fiber cable, and that is nothing but similar to that of the electrical cable, but containing one or more optical fiber that are used to carry the light. That means whenever we are using the twisted pair waveguides, all of this, the speed of the data is going to be less. Why? Because in the fiber optic cable we are carrying the data in the form of light. So the data which is carrying in the form of light is going to be having the higher speed when compared with our electromagnetic waves. So like that, we are going to be preferring the fiber optic cable for having the high speed of data. Okay, the optical fiber elements are typically individually coated with the plastic materials that we are going to be calling as plastic layers, and it is going to be contained in a protective tube which are going to be suitable for our environment and where the cable is going to be used. That means it will not affect by our environment. And we are having different types of cables, and different for the different applications we are having different types of cables, and it is mainly used for our long distance telecommunication and which is providing the high speed data connection between our different parts of a building. Why? Because today's the telecommunication is going to be done under the ground, that can be using the fiber optic cable. So how it looks means like this, it is having the inner fiber and is having some clad material, and above that it is having some buffer material, and above that the secondary buffer material, and like the coax we are also having an yarn which is going to be removing the interference of our noises or disturbances to our original conductor. And originally the overall cable is going to be shielded or covered with our cable jacket which is made up of a fiber. Okay, so like this we are having the fiber optic cables, and mainly the fiber optic cables are going to be used in telecommunications, long distance telecommunication, inter-exchange. Okay, and it is mainly used for our video transmissions, that is television broadcast, cable televisions. Okay, remote monitoring, and it is also used for our broadband services, and it is mainly used for our military applications. Okay, so like this, based on our applications we are going to be preferring the fiber optic cable. And in this session I have said about the what is the parallel transmission line, and what is the twisted pair transmission line, and what is the coaxial cable, and what is an waveguide, and what are the fiber optic cables. Okay, so next have a quiz on this. So the first question is, identify which of the following is not a transmission line. Identify which of the following is not a transmission line. The first option is telephone lines, the second option is power transmission, and the third option is underground cables, and the last one is cavity resonator. So what is an answer? Please note this question. So identify which of the following is not a transmission line. So what is an odd one in this options? Okay, the first option is telephone lines, second option is power transmission, and the third option is underground cables, and the fourth option is cavity resonators. So what is an answer? That is D, cavity resonators. Why? Because under the microwave frequencies we are having special types of the oscillators, amplifiers, like that the cavity resonators are going to be used in our multi cavity crystal materials. We are going to be using the cavity resonators. The first one is the telephonic line, which is nothing but a transmission line, and the power transmission is comes under the lines only, and underground cables are going to be fiber optic cables, and the last one is the odd one, that is cavity resonators. These are going to be used for our microwave resources or microwave devices. So under that we are having some multi cavities resonators. Under that it is going to be used, and it is not a transmission line. So the types of transmission lines are telephonic lines, power transmission lines, underground cables, coaxial cables, fiber optic cables, and etc. So the cavity resonators are not a transmission lines, they are the components that aids the maximum transmission. Okay, this is an correct answer. Next question. The open wire transmission line consists of. The open wire transmission line consists of. The first one, that is A option is conductor, B option is dielectric, and the third one is both conductor and dielectric. The last one is either conductor or dielectric. So the open wire transmission line consists of. The open wire transmission line is nothing but a parallel wire type. Both are same. Okay, so what is an answer? Please note this question. The open wire transmission line, which consisting of the A option is conductor, B option is dielectric, and the third option is both conductor and dielectric, and the last one is either conductor or dielectric material. Okay, so what is an correct answer? That is C, both conductor and dielectric is going to be having in the open wire transmission line. That means which consisting of conductor at the same time dielectric. The open wire is a common form of transmission line and which consisting of conductors. The conductors of such lines are considered to be in a parallel and that are going to be separated by a dielectric. Why? Because I have said that the two conductors are going to be there in the parallel wire type, and under that the two wires is going to be, one wire is carrying the original data and the second wire is going to be acting as an ground. Okay, so that means these two are going to be two conductors, and for separation of two conductors we are going to be having some spaces which will be acting as an dielectric. So for that reasons the open wire transmission line which consisting of both, that is conductor and dielectric. Okay, that is an correct answer. Next question. Telephone lines and power lines are open wire transmission lines, whether it is a true statement or a false statement. That means telephone lines and power lines are open wire transmission lines, whether it is a true or false. So please note this question. So the telephone lines and power lines are open wire transmission lines, whether it is a true statement or a false statement. That is, it is a true statement. That means telephone lines and power lines are going to be the open wire type. That is, open wire is nothing but it is a parallel wire type. Okay, so it is true. The open wire lines are going to be long and used for distinct wire communication. So such lines are telephone and power lines. That means open wire is nothing but used for our longer communications. So distance communication. So for that reasons the telephonic lines are used, and at the same time the power lines are also going to be used with this open wire type. And next question. The cable transmission line consists of. The cable transmission line consisting of. The first option is conductor, and the second option is insulator, and the third option is insulated conductors, and the fourth option is insulated conductors with dielectric. The cable transmission line consists of. First one is conductor, second option is insulator, third option is insulated conductors, and the fourth option is insulated conductors with dielectric. So what is an correct answer? Please note this question. The cable transmission line consists of. The first option is conductors, second option is insulators, and the third option is insulated conductors, and the fourth one is insulated conductors with dielectric. So what is the correct answer? That is D. The cable transmission line consists of insulated conductors with dielectric materials. Okay, that means the cable lines are underground transmission lines, and the line consisting of hundreds of individual paper insulated conductors twisted in pairs and combined inside a protective lead or a plastic sheet, which is usually a solid dielectric material. That means whenever we are using the cable lines that are going to be underground lines, okay, so which consisting of number of twisted pairs in that, and that is going to be combined inside a protective coverage, that is calling, which is made up of lead and at the same time plastic sheet. So that is going to be acting as an solid dielectric material. So for that reasons the cable transmission line which consisting of insulated conductors with dielectric material. So like this it can be having two, that is insulated conductors with dielectric materials. Next question. The coaxial cable consisting of. The option A is conductors, option B is dielectric, option C is conductor with dielectric, option D is two conductors with dielectric material. The coaxial cable consists of. The first option is conductor, and the second option is dielectric, and the third option is conductor with dielectric. The fourth one is two conductors with dielectric. So please note this question.